In the southeast United States, fire management plays an integral role in restoring and maintaining plant communities. Management in the longleaf pine ecosystem is often based on historical conditions or target environmental conditions for conserving rare species. Although historical conditions, also known as reference conditions, and the habitat requirements of rare species are certainly great starting points for restoration and management, obtaining management goals may come at the cost of landscape heterogeneity. Currently, some longleaf pine forests are burned during the growing season, on set rotations with 2 to 3 year fire return intervals being common. In addition to prescribed fire, management may include mechanical removal of hardwoods. The intention of these management actions is to create or maintain longleaf pine dominated stands with open canopy conditions, minimal midstory, and an understory dominated by regenerating longleaf pines, grasses, and forbs. Though these structural and compositional conditions are critical landscape features within the longleaf pine community, heterogeneity is also important. In recent years, some researchers have called for more variation in management activities. More variation in prescribed burning may promote natural heterogeneity, which can have positive implications towards preserving biodiversity. One important consideration is how frequent fixed-interval growing season fires affect the structure and composition of historically significant hardwood communities. Data supporting more variable prescribed fire regimes is evident in fire scar data, which suggests that the average fire frequencies throughout the longleaf pine ecosystem range from 2.2 to 6.7 years. Furthermore, the spread and extent of fires would have depended on environmental conditions such as topography, season, time since last fire, and microclimate. Historical variation in frequency, season, and environmental factors likely allowed for more variable intensity, severity, and extent than is present under the modern-day prescribed fire regime. Let's take a walk around a sandhill longleaf pine community managed on a 3-year growing season fire rotation while we get into the details of this topic. Recent research conducted on xeric sandhill longleaf pine communities managed with the 3-year growing season fire rotation reported the occurrence of a fire intensity gradient associated with fire application and proximity to fire breaks. Researchers showed that oak and persimmon stems and mast abundance was greater closer to fire ignition points than in the interior areas of the longleaf pine stands. This area is one example of such observations. There's dense oak and persimmon stems close to the fire break. Let's go take a look at some of the other evidence. At 5 meters from the fire break, we're looking at the scorch height of this pine. The scorch height is about 1 foot, which indicates that the fire was a low intensity surface fire near the point of ignition or the fire break. Let's go take a look a little further into the stand. At 20 meters into the burn unit, we're seeing a decreased density of hardwood stems, especially of the same structure and composition. If we look at the scorch height of this pine, it's about 4 to 5 feet, which indicates that the fire intensified as it moved into the stand. Let's go take a look a bit further and see where the scorch height is 50 meters into the stand. At 50 meters from the fire break, we could see that the structure of the forest stand has changed quite a bit. Canopy conditions are much more open, and the midstory is much less prevalent. If we take a look at the scorch height on this pine, it's well above my head. I would say that it's at least 10 feet. I would say the fire was certainly more intense in the interior than near the fire break. The lack of heterogeneity in vegetation composition and structure across the landscape can affect the vertebrate community by decreasing species richness and biodiversity. For example, a landscape lacking variation in vegetation structure and composition can influence the bird community by decreasing options for foraging or nesting. Hardwoods, especially fire-tolerant oaks, have long been recognized as an important component of the longleaf pine community. Research has shown that hardwoods would have been distributed as patches of mixed-age trees evenly interspersed within the longleaf pine interior. Not only does the fire regime enable less fire-tolerant hardwoods, like persimmon, to establish and survive near the fire breaks, but it may also reduce heterogeneity by limiting establishment and survival of fire-tolerant hardwood species within the interior portions of the longleaf pine stands. Let's take a look at some slides from a recent effort to map vegetation types in this xeric sandhill longleaf pine community.
We can see on these slides that hardwoods, the lighter green color on the map, are denser near the firebreak than in the interior portion of the stands. The interior portions seem to have less hardwood composition and more pine and open in the darker green and tan color. From this, we can infer that these areas near firebreaks have higher canopy cover and hardwood basal area.
Here at this site, I think we're lucky. To even be at the point of discussing the long-term management of the longleaf pine ecosystem is one that's seldom reached elsewhere in the species range. While the need for frequent growing season fire can't be overlooked, we should ask ourselves, how is the current fixed return interval fire management regime influencing management outcomes? Are fixed fire regimes restoring and maintaining forest conditions representative of historic conditions? What effects do fixed fire regimes have on the structure, function, and biodiversity of forests, and at what scale? Natural variation in fire intensity, severity, and extent across the landscape would likely result in much more variable forest conditions than fixed interval growing season burn regimes allow. The resulting landscape would be a constantly shifting mosaic of pine savanna and woodland interspersed with patches of uneven aged hardwoods. While some areas would have little to no hardwoods, in other areas hardwoods would survive to mid-story and canopy height. Such hardwood patches would result in different surface fuels, moisture regimes, and microclimates, which would have implications on the local fire regime within the patch. When developing long-term fire prescriptions, managers and natural resource planners should consider implementing strategies based on the full suite of historic data. By this I mean, rather than developing fixed interval rotations based on historic averages, planners should consider the range of fire frequency as well as variation in season and ignition conditions. Not only would these considerations serve to promote landscape heterogeneity and biodiversity, but they would also be more representative of historic disturbance regimes in the longleaf pine ecosystem. As biodiversity and forest resilience face threats in the form of future development and climate change, it's crucial to implement adaptive management and incorporate new scientific developments and understanding into the management of the longleaf pine ecosystem.